This is an EE-177 power electronics presentation by Benjamin Chainey for a DC motor controller project. The goals of this project were to have bidirectional rotation control of the motor. This would give clockwise and counterclockwise rotation directions. Also desired was to have variable speed control for low RPMs, rotations per minute, and high RPMs over a variable speed range. This is a block diagram of the circuit components used. First, there was a PWM controller, which would create the switching signals for the power electronic MOSFETs of the H-bridge. This switching signal would get fed to the MOSFET gates to determine the current direction flowing through this 3-volt brushed DC motor. Speed control was fed into the PWM controller, whereas direction control was fed into the H-bridge through a hard switch. The pulse width modulation controller design was based on 555 timer IC chips. My project used a 556 timer chip, which is just two 555 timer chips in a single package. The 555 timer can be used in different modes of operation. Astable mode creates an oscillating circuit with feedback. Monostable mode is a one-shot delay signal circuit, which will create a single high duration pulse for a given triggering signal. This allowed the astable oscillator circuit to create a frequency of, in essence, a pulse train of triggering signals, which would be specified at a specific frequency based on the RC time constant fed into this circuit. This triggering signal would go into a second RC time constant, which was connected with this potentiometer to create varying pulse width durations. This is the switching signal that went to the H-bridge. The H-bridge had 4 transistors, 2 P-channel MOSFETs, and 2 N-channel MOSFETs. This hard switch would determine the actual current for the rotational direction, either clockwise or counterclockwise, whereas the switching signal coming over it would determine whether the voltages were on average higher or lower on different sides of the MOSFET. This would determine whether the current would flow in direction for clockwise or counterclockwise based on whether or not the voltages were higher on one side of the motor or the other. The results of this project were quite successful in that I was able to reach the goals of bidirectional rotation control with variable speed. PWM controller duty ratio came out to a nice range of 8% to almost full power at 99.4%, which gave a wide range of speed control. The oscillator frequency came out to 1.2 kilohertz after the RC time constant values were created by selecting different component values for the resistors and capacitors. Also, an observation I made was that there was some reactive effects that were introduced into the system to create noise and distortion, most likely from the inductive nature of the DC motor windings. This could probably be mitigated by including a parallel filter across the lead terminals of the motor. This is the oscillator trigger signals from the astable 555 chip. This is the PWM switching signal operating at 8% duty cycle, the lowest speed of the rotation for the motor. Half speed at 50% duty cycle after the potentiometer was adjusted accordingly. And then full power for full speed from the PWM switching signal. This is when the RC time constant is allowing the highest possible duty ratio. This is the circuit that was built, first on a breadboard, and then the PWM controller was soldered together on a perforated prototyping board. Now I will demonstrate a video of the circuit in action. Notice the inductive noise going on here from the motor. Increasing the speed of the motor. I'm now going to flip the direction of the motor. Watch the momentum shift. That'll be all. Any questions? Feel free to ask me whenever you see me.